MAVEN is a Mars orbiter, not designed to take pictures of Mars, but really with chemical sensors to understand how the present atmosphere is escaping from Mars, and then through modeling try and extrapolate that back in time and try and understand whether the ancient atmosphere of Mars was similar or different than it was today. MAVEN stands for Mars Atmosphere and Volatile Evolution mission. The NGIMS experiment on MAVEN is the neutral gas and ion mass spectrometer. And this experiment is a quadrupole mass spectrometer with 2 ion sources designed to look at both neutral gases and ions in the upper atmosphere of Mars. In fact, as we dip down into the atmosphere, we will measure the altitude variation of those chemical constituents. We'll look for the composition. We'll look for how that composition changes with solar events like big solar flares and solar activity. And we'll do that for a whole Earth year on many, many orbits around Mars.
So the philosophy of NASA's Mars program has been follow the water. But where did the atmosphere go was still a lingering question. And so MAVEN is designed to figure out whether or not that atmosphere could have escaped away to space.
The MAVEN payload, all of the instruments on it are designed to examine the processes by which gases escape from Mars. When we look at the ultraviolet light, we can tell what the atmosphere is composed of. We can also tell its temperature. Measure variations in the composition and temperature as we look at different parts of the atmosphere at different seasons on Mars, different times of day.
The imaging ultraviolet spectrograph is the most...
So we have to put those magnetometers as far from the spacecraft as we can, and we've done that by putting the sensors at the very outer end of the solar arrays.
The magnetometers, even though they're small, simple-looking instruments, there's actually a great deal of sophisticated electronics and testing and calibration that goes into building them. They're so sensitive that we ask everyone to use non-magnetic tools when they're working on them, even if you had a tiny little...
Scientists also think that Mars lost its atmosphere over the course of billions of years, gradually transforming into the red planet we know today. NASA's MAVEN spacecraft will help provide clearer answers regarding Mars's climate history, and scientists think several processes have had an effect. For example, there are a series of what are known as plasma processes that can slowly strip away a planet's atmosphere. These processes are started by the sun, which emits light in the form of high-energy photons. When a photon at an extreme ultraviolet wavelength enters a planet's atmosphere, it can run into a molecule that makes up the atmosphere's gases. The molecule absorbs the photon, and the energy from this impact can kick off an electron, leaving behind an ion. This stray electron will eventually recombine with another ion, and the energy the electron gives to this reaction is sometimes enough to split the molecule into its component parts, give those parts a lot of speed, and launch them out into space. And although this process occurs continuously in most atmospheres, with the self-maintaining cloud of ions and electrons forming a planetary ionosphere, the escape of atoms over billions of years can contribute to the overall loss of a planet's atmosphere. This could even turn a blue, water-covered planet into a planet just like Mars, and MAVEN will help us figure out exactly what happened.
In order to confirm the remarkable discovery of an ancient habitable environment, and to see if there's any variation among the rocks within Yellowknife Bay. We're now headed in the direction of our ultimate destination, Mount Sharp, 5 miles and several months away. Along the journey, the science team will continue to explore for evidence related to the habitability of ancient Mars.